Hello, my name is Hans. I am a mechanical engineer and I'm using CAD software almost since 1990, actually 1989. All kinds of CAD software, and lately the last decade basically I'm involved with Autodesk Inventor. I use it a lot and it's a wonderful program in my view. And I was wondering, what if the guy who invented this bicycle had CAD software? So that's why the title of the theme is What If They Have 3D? So, well, we don't know how he would do it, but let's just assume that we are reinventing this big bicycle with a big wheel. And um, I was looking, I tried to find drawings. It's very hard to find, and they are very incomplete. And I just thought, you know what? They didn't have drawings either, so they had to start from scratch. So let's start from scratch, and I have this nice example from this guy who's riding this bicycle in I guess in England, in Britain. And well, let's just start. Okay, so I have Autodesk Inventor. I already have this made, this wheel, but I make it again because this was actually recorded the wrong way. So let's just start and make a new rim. I started with a big rim, and I'll try to show you how that works. And I'm first going to save it. I'm using Autodesk Vault. I will explain in another video probably what it means. It's basically a glorified Explorer, very good glorified Explorer to be honest. And I'll explain it another time. So I'm going to save this thing, and I'm going to use this link, this path to save it, and I call it rim02. Rim01 already exists. I'll do it again, save. So there we are. So how do we do this? Well, what you do with all these 3D softwares, you start with a sketch. So let's just start with a sketch, and you have three planes to work to start a sketch on. It's the IZ plane, the XZ plane, and the XY plane. I like to use the XY plane because I'm more familiar with that, but it doesn't matter. Anyhow, new sketch, and then I'm gonna up front. I'm gonna guess some dimensions. Okay, so let's see. We have the diameter of the rim, and when I look at this picture, I think it's like the guy is probably 175 meter, 1.75 meters. So let's say that this rim would be 1.3 meter, I guess, something like that. Okay. So I'm going to type in the names in these parameters. You don't have to do it, but it is much easier to control your model after you made it and even while you're making it. So diameter rim dia 01. I use 01 underscores. I use underscores because that's how you can make like a space. The space will not work in parameters, and in many other cases it is still kind of, it will work or it doesn't work. So I always use the underscore. The dash doesn't work because it sees it as a minus, and here you fill in the dimensions. I use millimeters, the metric system, because I'm more familiar with that and it's more precise also, but it's also a matter of taste. So then let's typo, then I say rim width 01. Well, what will be the width of the rim? Let's say it's 3 centimeter, so that's 30 millimeter. And then rim height, I will demonstrate. When you follow me, you will see what happens. 01, let's say that is 20 millimeter, and I say I'll make some chamfers for 01, I know that's 5 millimeter. I can also do this, copy to 4 millimeter, and then fillet 01, I don't know, 2 millimeter, fillet 02, let's say 3 millimeter, and then spike hole 01, there's probably only one, but let's say that it's 2 millimeter, I think 1.5, and then the number of spikes I counted I counted before. There seem to be like 80 spikes around that. Spike number 01. That's obviously not millimeter. That is angular. I mean unitless. So that is like 80. And then we have some angles. 01, 45, angle 02, 30. Okay, let's just start, and let's start with the rim is the inner diameter basically. Okay, well yes, it is. That's easier. So, and then I make this line. It is something like this. This is way too big, I guess, so let me correct this a little bit. I'm gonna add some dimension, but otherwise it's very confusing. I use this line to make construction lines, otherwise the lines are very thick and I don't really like that. Nothing wrong with it anyhow, but okay. And then this line will be the revolving line, so it will be the center line. So I'm going to make it the center line, and you can see, look, when I now add a dimension, not from the middle, just from the line, that's kind of big. Rim diameter right, so there we are. Oops, what's happening here? Well, what's happening here is it's just very big, everything, so we just make it much smaller. I'll do this. And then the rim width, of course it will be very small. And make this line again. So, okay, and now oops, this is the normal line, so I'll switch it to normal, and then this line, and then something like this, and then we mirror this thing, and then we add the dimensions. So mirror, the mirror line is here, apply, done, and we extend this line. So now, and you see this line have different colors. This line is black because it's basically settled, and we're going to make some angles. Angle 1 was 45 degrees. Okay, something right. It should be angularity. It's degrees. Angle 1, and this is angle 2, dimension, and why I do this, because yeah, you can later control it better. Let me see. Are they really? I think they are not mirrored anymore. They're already there. Okay. Now we add the width. Well, that's way too big, but it will correct. Rim width. There you are. And then the rim height. Yes. Something is very wrong. I clicked the wrong one, I guess. Rim height. There you are. Okay. And then we set chamfer 1. And chamfer 2. Make it 2. There you are. And because this is mirrored, they stay mirrored. So they, I don't know why it doesn't show it, but. And then we make, we can make the fillet here. I'm going to do it in the model because it's more easy. So offset. And then we set the offset thickness. This is the thickness of the rim, so that will be thickness, rim. I have not made that yet. I'll make it. Rim thickness. I like to write out the whole thing just because it's more clear, so that you don't need to guess what does it mean again. So rim thickness, and other people use abbreviation, whatever you want. I think this is more easy. We're going to make it still purple, so that means it's not fully constrained, so I make it perpendicular, and then I mirror this thing again, so that we don't need to bother when it's change it. And I don't know why this is apparently right. So now we have the rim, basically the rough form of the rim. Here will be the tire go in, and this will be the steel rim. And I click finish. Now the sketch is finished, and then now we can revolve the thing. I'll do refresh, revolve, and there you have it. It automatically finds the most logical center line, and it revolves the whole thing around it. And we're going to add a material. I'll make it steel mild because it looks good and it's kind of realistic. Steel mild, where are you? And why I like CAD systems like Solid, I like SolidWorks, also Solid Edge, and also Inventor. These CAD systems use solids, and with a solid you can add material, and it really gives the right weight also. Let's try, because there is a way to figure that out. Properties, physical, update. This thing will weigh almost 4 kilo. And if you change the units, you get it in pounds and everything. So I use metric system. 4 kilo will be allowed around 8.5, maybe 9 pounds, something like that. Okay. And we're going to save this thing. Save or Control S, and then check it in. So now it's in my sophisticated explorer called Vault. I'll check it out again. Now it is in the Vault too, so we have like a backup, you know. And now we need to make a hole in it. So holes for the spikes, you know. So let's make some holes, And how do we do this? Well, we're gonna make a plane, and the plane will be tangent to this edge. And later we make some fillets, but I will do this now because it makes the process easier. So plane, tangent to surface parallel to plane, that's a good one. Tangent to this surface, parallel to this one. There you have. And with this plane, once you have a plane, you can add a sketch on it. That's the beauty. Without a plane, you cannot make a sketch. So, and then we use this button, slice graphics. So now, when I turn this thing a little bit, I only have this view, which is perfect because I'm not bothered by the rest. Okay. So, and to make this hole in the middle of the two planes and in the middle of the rim, I'll use a trick, and it's called project geometry. That's this one. So I'm going to project, and the dot should be in the middle, but we're not sure of it. In the previous one it didn't work out. So I project this line and I project this plane, and now we have two lines, which the intersection of these two lines is exactly the middle of the middle. Okay, so I'm going to make these construction lines so they are not so in the face, and I put this point just here. Now the point is like glued to this line, but not to this line yet. So we're going to use this constraint. We make this point glue, as it were, to this one, and now we know that the dot is in the middle. And why do we need this dot? Because we need the dot to make a hole. Okay, so we finish this thing, and now I'm going to switch off this plane because it's kind of hindering. So now we have two lines, which in the middle is a dot, and this dot will represent where the hole comes. So we're going to make this hole, and I'm going to here select the hole diameter. I think I already did that, spike hole 01, yes. How much is that again? So I hover over it, diameter 1.5 millimeter, okay. And I'm going to use symmetric because now the hole goes in both sides, because in this side of the hole here, this side, the material is a little bit bended. If I don't do it, I'll show you, then you don't see the hole. You see only a little bit. You see there's like a sort of an envelope, like a slot in it, but the hole is there. When you turn this thing, here you see the hole, but it's not through. And that is because the bending on here is already bended. So CAD software is really very mathematical. So it doesn't, it's like dumb in a way, but also smart. So now we're going to make this hole in both ends, both directions I mean, and now you have the hole through and through, you see? That's what we need. Okay, and now we determined that there will be allowed around 80 holes. I counted the spikes from the picture, and it's like 20 per 90 degrees, so that's 80. Let's make this hole, and we make a pattern, so circular pattern. We click this hole, that will be that will be patterned, and then we click here the rotation axis, which will be if you look here, you see the x-axis, so we will use the x-axis as a rotation one. There we go. And then we say this little arrow that brings you to the parametrics. Okay, so in the previous drawing or model I used spike number 1, so it's the same. Then it gives some kind of a warning which I ignore, and then it's 360 degrees. You see here the green dots where the holes is supposed to come. So now we say okay, there we are. We have 80 holes. And to make it a little bit more smooth, I'm going to add some, make it a little bit nicer with some some fillets. So I'm going to, and to show you, I'm going to show you a half section, then you can see it better. There you are. And then I only do it on the outside because it's just visual. In the reality, there will be because this thing will be bended. There will already be a fillet, but I'm not going. I'm only show it on the outside now. So fillet, we can see fillet 01, I believe it was. I don't know how much I hover over it. 2. Let's see. Maybe that works. Not sure. 2. Oops. Again. So 2, 2, 2, 2, 2, 2. Right. Now this is what we want. And now I remove the section view. I'll make the. Now we have a nice rim. Okay. That's the video for now, and let's see how we go further with the next video, where I will show other elements of this bicycle. Thank you for watching, and I'm asking you to like and subscribe, and then the more you do that, the more videos I can show and the more you can enjoy my videos. Thank you very much for watching. Bye bye.